Hi, it's Glenn, and I'm here to run through the calculations of experiment number 2 for the empirical formula of copper oxide late night lab. Now, there are some calculations in here that are pretty complicated. I think you have seen these, or you will see these this week in the lecture portion of the course. But I still want to do this in some detail just because somebody asked for it, and I want to help as much as I can. So here the mass of the copper powder that I used. Okay, my copper powder. Okay, this is experiment 1, sorry. Go back to experiment 2. All right, so here the mass of copper 2 sulfate pentahydrate that I used was, here it was, part A, it was 4.110 grams. Wow, that's kind of a funny color. Let me get back to black. Okay. Now for part B, the molecular weight, oh, it's still blue, how weird. The molecular weight, what is the molecular weight of copper 2 sulfate pentahydrate? Do you know how to calculate that? You know, copper 2 sulfate pentahydrate. You calculate the molecular weight, also known as the molar mass, by using the periodic table. We're going to calculate this in grams per mole. You may already know that the mole is a special number, just as the number 12 is the number for the dozen. This number here, you don't have to memorize this, but this number is the special number for the mole. So the mole is just this many things, this number of things. It could be anything. If you have a mole of golf balls, that would be like enough golf balls to fill maybe a couple of Olympic swimming pools. But I mean, maybe even more, maybe to fill the whole world. But anyways, a mole is just a very large number that was designed specifically so that you could calculate molar masses very easily using the periodic table. So you know the average atomic mass for copper is 63.55 AMU. Well, the number called the mole is designed so that it will also be 63.55 grams per mole of copper in a mole of copper. That's what the purpose of the word mole is. So anyways, you add up all these grams per moles gotten from the atomic masses on the periodic table. You just add them all up. 63.55 plus 32.066 plus, there are 4 of these oxygen atoms, so it's going to be 4 times 16.00 plus, now there are 5 of this whole thing. That means 5 oxygen atoms, and 5 times 2, 10 hydrogen atoms. So that's going to be plus 10 of the hydrogen, which is 1.008 grams per mole, plus 5 of the oxygen again, which is 16.00. Now just to be clear, I'm getting these numbers from the periodic table. Oxygen 15.9994, that rounds to 16.00. Sulfur 32.066. Copper 63.546, that rounds to 63.55. Then hydrogen, that rounds to 1.008. So that's where all these numbers come from, and that's how to calculate the molar mass, or the molecular weight of anything. Okay. So when you add that up on your calculator, you get 249.72 grams per mole. It's very important to use the correct units, grams per mole. You'll probably have a few more significant figures here. That's appropriate. Here, actually, let me do this right and use all of the necessary significant figures. So 63.55 plus 32.066 actually, here, let me use even more significant figures. Let me use the actual numbers from the periodic table without any rounding. Okay, plus 4 times 15.9994 plus 10 times 1.00794 plus 5 times 15.9994. Okay, it's 249.686. Yes, the max number of digits after the dot that I have is how many? Let's see. There are 4 digits after the dot. 3 digits, 4 digits. Okay, so I have to round the answer to 3 digits after the dot, not 4 digits after the dot, because in addition and subtraction, the answer has to be only as precise as the least precise number that was used in the math. Okay, so the answer is 249. 686. Sorry about this flipping around here. 686 grams per mole. All right. Now the other way to calculate that, since this is an online course, is to just Google. If you Google molar mass and then you type in the formula, you don't even have to respect the capital letters. You know, Google will figure it out for you. It's very nice, right? You do have to include the 5H2O, however. Otherwise, you get the wrong answer. Okay, yeah, that was a little complicated, right? Okay, now that I know the molar mass of, the molecular weight of copper 2 sulfate pentahydrate, I can calculate the moles that I had. So, 1 mole of that stuff is 249.686 grams of it, right? We just calculated that, and we used 4.110 grams of it, didn't we? Right there. So that means what we had in moles was 4.11 divided by 249.686, 0.01646. 0.01646 moles of that copper 2 sulfate pentahydrate, blah, 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 blah. All right. Now remember the significant figures. There are 6 figures here, but there are only 4 figures here, so the answer has to have only 4 significant figures. Now, the next one, the next part is moles of copper. Here's where some of the complication occurs. I know that there is 1 mole of copper in 1 mole of this material. So to write the complete formula, it was okay. You see here there are 4 moles of oxygen. You see there's 1 mole of sulfur. You see there's 5 times 2, 10 moles of H. How many moles of copper are there? Just 1, right? So 1 mole of copper is the same as 1 mole of copper 2 sulfate pentahydrate, right? So what does that mean for the number of moles of copper that I actually had? Well, this is the number of moles of copper 2 sulfate pentahydrate I had. So I can cancel these moles of copper 2 sulfate pentahydrate if I write in here 0.01646 moles of copper 2 sulfate pentahydrate. Okay, so if I wrote this up here, I could cancel moles of copper 2 sulfate pentahydrate with this moles of copper 2 sulfate pentahydrate, and I would get 1 times this number divided by 1, so that equals this number, of course, 0.01646 moles. Moles of what? Moles of this non-crossed out item, copper. Okay, so that's how many moles of copper I had. 0.01646. Now let's get a little more complicated. Remember that I used a test tube and a Bunsen burner to turn this copper material into copper oxide, which is black. Okay, this is a little false. At no point did you actually add pure copper to the test tube, right? We used copper to sulfate pentahydrate and sodium hydroxide. But anyways, sorry for that aside. Okay, now the initial mass of copper in the moles of copper from the copper 2 sulfate. Now, that is not something that you took as data. They're asking, okay, in experiment 2, you added this to the test tube. They're asking how much mass, how many grams of copper was in this that you added, right? So we know that we want grams of copper because it says initial mass of copper. So I'll start with grams of copper. I know that there are 63.55 grams of copper in 1 mole of copper. It says so right there. Now, how many moles of copper did I have? Well, I just figured that out, didn't I? So it was 0.01646 moles of copper. So this neatly gives me the grams of copper that I had there, 63.55 times 0.01646, and that was 1.046 grams of copper. Notice, folks, that I have 4 significant figures here because this is 4 significant figures and this is 4 significant figures. I need to have 4. It cannot be 1.05 grams of copper. It would be the wrong answer. Of course, all my numbers should be different from yours, but you get the idea. Next item is part B on number 7, the mass of copper oxide obtained. Okay, now this is a measurement. So I'll go back to my notes. There it is. The mass of copper oxide was 1.309 grams. How did I do that? It is the mass of copper oxide plus test tube minus the test tube. In other words, it is the mass of this minus the mass of the empty test tube. This, right? So the mass of this one minus the mass of this one. Yes. That's gonna, what's that gonna get you? That's gonna get you the mass of, that's gonna get you, when you do the subtraction, you know, the answer that you're gonna get is just the mass of this black stuff alone, which is copper oxide, which is what I want. So, there it is. Here. Here, yes. So that's 1.309 grams. Who cares? The next problem cares. What is the gain in mass? All right, so this is copper oxide, 1.309, and my last calculation was the copper 1.046. So 1.309 minus 1.046, that should equal the grams of oxygen, because the only difference between the copper that I added in the form of copper 2 sulfate pentahydrate and the copper that is in this black stuff is that in this black stuff some oxygen atoms from the air got incorporated chemically. There was a chemical reaction to make copper to oxide. So what am I trying to say here? I'm trying to say that, yes, that's it, by subtracting the mass of copper 2 oxide there minus the mass of copper that I added by adding copper 2 sulfate pentahydrate, by doing this subtraction problem, I get the mass of just the O. This is copper minus copper. Okay, so you get the idea. Right, so that's 0.263. So that's 0.263 grams of oxygen. I have lost a significant figure here because it was 1 minus 1, but that's okay. 0.263, there are 3 significant figures there. The rest of the work is going to have only 3 significant figures. Okay, so that is the gain in mass equal to the added mass of oxygen, my 0.263 grams of oxygen. Now, how many moles is that? Right now, let's convert it to moles then. I'm going to convert this number into moles. This is 0.263 grams of oxygen, okay? Oh, so I can tell why I got a question about this. Yeah, this is very complicated. I'm converting to moles. I know that in 1 mole, there are 16.00 grams of oxygen. 1 mole of oxygen, that's that many grams of oxygen. And how many grams of oxygen did I just calculate? What was it? 0.263. So 0.263 grams of oxygen. So it's 0.0164. The answer is 0.0164 moles of oxygen. That number seems familiar, doesn't it? So the mole ratio in number 8, the mole ratio is going to be 0.0164 moles of copper over 0.0164 moles of oxygen. And that equals 1.000. No, sorry, 1.00. Okay, so that mole ratio is just 1. Now, how do you get the empirical formula? Okay. Let me show you how to get the empirical formula one more time. Element. How many moles of this did you get? How many moles of this did you get? But you can't have a decimal for a subscript in a formula because you can't have a decimal amount of copper atoms. So you divide by the lowest. Well, they're both the same, so they're both the lowest. This becomes 1. This becomes 1. So you have Cu1O1. In other words, CuO. That is the empirical formula. You need to be able to find that on your own. So ask me more questions if you need some specific help with that process. All right? So you have seen me do that with my numbers. You do that with your own numbers. Okay? Now, number 10, I believe, is the last item. Calculate the yield of copper oxide. First of all, how many moles of copper oxide would you expect? Well, this is the equation. Okay, so remember that I had a certain number of moles of copper. I had 0.0164 moles of copper right there. Okay, so how many moles of copper oxide would you expect? Well, it takes 2 moles of copper to make 2 moles of copper oxide, meaning it would take 1 mole of copper to make 1 mole of copper to oxide, meaning it would take 0.0164 moles of copper to make 0.0164 moles of this copper oxide. So the answer to the expected number of moles of copper oxide would be 0.0164 moles of copper oxide. So that's simple enough, right? But what actual mass of copper oxide did we get? Remember, I already forgot. It was 1.309 minus. It was 1.309 minus the mass 1.046, was it? Something like that. Yes. So it was 0.263 grams. So it was. We actually got 0.263 grams. But what is that in moles? Let's see. Actual moles of... Oh yeah, so the actual moles of copper oxide. So this is the grams of... Oh no, I'm sorry. The 0.263, that was the oxygen. That was the oxygen, remember. The grams of copper oxide are right here in the notes. Let's see, my lab notes. Okay, you measured this in the lab. The mass of copper oxide is 1.309 grams. So, what I got was really... Okay, so I got 1.309 grams of copper oxide. But they want that to be in moles. So let me convert that to moles. In 1 mole, there are 63 copper oxide. In 1 mole, there are a certain number of grams of copper oxide. Let's ask Google how many grams there should be. Molar mass of CuO. What is that? 79.545 grams per mole. Oh, sorry, I forgot it already. 79.545 grams per mole. 79.545 grams in 1 mole. And we want moles, and so how many grams was it? 1.309 grams of CuO. Right? Right. And that is going to equal... Okay. 1.309 divided by 79.545. 0.0165. So that's 0.0165 moles of copper oxide. Okay, that's it. So okay, so I got the actual mass, I got the actual moles. So number 11, calculate the percent difference between the expected and actual values. Let me show you how to do that. So I got 0.0165 moles. I was supposed to get 0.0164 moles. Right, so let's find the percent difference there. All right, you just take the difference between what you got and what you were supposed to get. It doesn't matter what order, because we ignore any negative signs. You see the formula that they gave has absolute value signs. That just means you can just ignore the negatives. So, oh, something funny happened on my notepad here. Oh, it's too big here. Is that better? Is that better? That's a little weird. Let me try this. Okay, something funny is going on with this. So, let's get another one. Okay, so 0.0165 minus 0.0164 divided by what you were supposed to get, which is 0.0164. Now, on your calculator, you need to press the equal sign after you do the subtraction, because if you press the division sign, you're going to get the wrong answer. 0.0165 minus 0.0164 equals divided by 0.0164. So my percent error is, this times 100%, 0.6097. So there are, so this is going to be 0.6% difference. Okay, why is it not 0.6097 or 0.6098? Why is it not 0.6110%? That's because of this subtraction problem. When you do this subtraction, you end up with 0.0001 divided by 0.0164. Now this is only one significant figure because zeros at the beginning are never significant. So that means your answer in this division problem needs to be only one significant figure. So there it is, 0.6% difference. Yeah, that was very hard. So please ask me plenty of questions. If you need additional help beyond this video, or if you need me to go over something in this video in a different way, or with more examples, I'll be very happy to do so. Thank you.